So I'm going to make this video as short as possible, so I might go kind of fast. This is going to be an independent t-test, also called a two-sample t-test. So if somebody's in one group, they are not in the other group, okay? So that's what makes it independent t-tests. So here's the question. The short version is, does active group learning show any kind of difference over the reading scores between the passive group learning? Okay, so whoever's in the active group is not in the passive group and vice versa. That's what makes it an independent t-test. So we're going to go ahead and state the null hypothesis. Null always states the same thing, that there's no difference between the groups. In other words, the mean group for group 1 is going to be the same as the mean as group 2. You can also do it like this. The difference between the means of the groups is going to be 0. Okay. So we're going to go ahead and do it by hand first. We're going to calculate the T-statistic, subtracting the means on top, divided by the pooled variation on the bottom. Pooled variance on the bottom. Let me pull up Excel to get these figures for you. Hold on a second. So here's the data, nice and neat. I simply went ahead and typed in average function. So there's the average for the active group. Standard deviation for the active group. Right here is the average for the passive group, standard deviation for the passive group. So I got these numbers, so let's go back to our calculations. And here they are. I'm just going to go ahead and plug these values into this formula. So I'm going to substitute these numbers into this formula. X1 is the top group, that's the active group. X2 is the passive group down there. So here comes the math time. And we're going to do some calculations. So the difference is 6.42 between the means. And we're going to do all the squarings of the standard deviations and divide by 24. We're going to add that together. We're going to take the square root of 2.32. We're going to get that. We're going to get the final t-test statistic of 4.22. That's a large t-test statistic. What that literally means is that the mean differences are more than 4 standard deviations away from each other. And remember, the rule of thumb is if your t-score, your t-test statistic is greater than 2 or less than -2, then you're going to have a significant difference between the groups. Okay, but let's go ahead and finish this out. We're going to go ahead and add to Excel. We're going to find out what the t-distribution is for 4.22. This is the formula, right? 1 minus t-distribution. Let me go ahead and do that in Excel. Please hold. Right? You pick a cell, any cell. You go up here. You can do it the easy way. Equals t and whatever pops up. We're going to use t-distribution. First number it's asking for is, what is your t-score? Ours was 4.22, comma. Degrees of freedom is the total number in the study, and there's 2 times 24, so that's 48 minus the number of groups. So there's 2 groups. So 48 minus 2 is 46, comma, and we're going to use the true cumulative, but we're going to subtract that from 1 because ours is we think 1 is greater than the other one. That's why we're subtracting it from 1. So let's put that in there, 1 minus. So that's going to give us our probability value, which is tiny. That E minus 0.05 is literally times 10 to the -5. Let me show you what that means. Okay. Literally, you move this decimal place over 5 times to the left. Bam, bam, bam. So the probability value is roughly 5, what is it? Tens, hundreds, thousands, 10,000s, 100,000s. So in other words, the probability that the null is true is 500,000s, which is not very reliable. So what you're going to do is you're going to reject the null because your calculated p-value is much smaller than the cutoff p-value, your alpha p-value. So real quick, I'm going to show you how to do this in Spss. So please hold. So here's a couple ways to do it. I forgot to tell you I'm going to do it in Excel as well. So Excel, pick cell, any cell, go to the function bar. You're going to go to, just go to t-test, right? Make sure you're in statistical. And array means column, right? So just highlight the first column. Array 2 is your second column, just the data, right? Tails. Since we are assuming one of these is going to be greater than, we're assuming that the active is better than passive. That makes it a one-tailed test. It's called directionality, okay? If we weren't sure which one was better, that would make it a two-tail. But we're assuming that one is going to be better than the other. And the type is, click on this, it's a two sample, and we're assuming the variances are the same. So that's what we're going to do. That makes this a 2. And we're going to click OK, and it gives us the p-value again. So this is the probability that the null is true, which we're rejecting that. So now let's switch over to SPSS. To do it in SPSS, you have to put it in a different format. Let me switch over to that real quick. Yeah, let me get it on screen for you. So for SPSS, you need to make a new variable. We're going to call it group, and you have to give each group its own number. So for us, number 1 means it's in the active group. So the first 24, they all get 1s. The second 24, they all get 2s. So I'm going to go ahead and cut and paste this into SPSS. So the first one is group. Second one is reading scores. Right? We can go over to the variable view real quick. And I'll show you how I labeled them. Right? Group, I gave them the values. 1 was active, 2 was passive. I made sure that the group was a nominal variable and the reading scores were a scale variable. But now we're going to do this real quick. Go to Analyze. Compare means. It's an independent sample t-test. Our grouping variable is the one I marked group. And our test variable is our DV. Those are the reading scores. We have to define the groups. Okay. We use the numbers 1 and 2. Click OK. Click OK. So here's our output for the t-test. And here's the first box, the Levine's test. Remember, that's one of the assumptions of a t-test, is homogeneity variance. In other words, the variance of the first group should be relatively the same as the second group, and we did not violate. If this sig value was less than 0.05, we would have violated that assumption. But our t-test score is practically the same, 4.2, and our degrees of freedom is the same, and the significance value is less than 0.001. Remember, ours was 500 thousandths. SPSS only goes out to the thousandths place value. But that's it. Hope you liked it. MGZ, out.